Today's video deals with the future value of an annuity, which is one of the four types of cash flows for the present value or for the time value of money. So in this type of timeline situation, what we have here is you invest an equal amount every period. In this case, looks like from all the way from today all the way for 5 periods, and the question is, what is that going to be worth at the end of the 5th period if given a certain interest rate? So the way we're going to solve these kind of problems is with the following formula, which includes using a table value that is called the future value of an annuity table. So the future value of an annuity is going to be equal to the periodic payment, which is these payments we've been making every time period or every year, times a table value, which is called the future value of an annuity, in which you will have to know the interest rate and the number of periods. And we'll be able to see what these 5 payments are going to be worth out here 5 years in the future. Here's our first example. What is the accumulated value of a $25 payment to be made at the end of each of the next 3 years if the interest rate is 9% compounded annually? Well, here's what this looks like in terms of a little timeline. You're starting right here in today, which is time 0, and you're putting $25 in after 1 year, $25 in after 2 years, and $25 in after 3 years, and asking the question, what is it worth right now at the end of 3 years? So that's the question mark, and we know what these things are. So the way we're going to solve this is we're going to ask the question, is the unknown in the present or in the future? Well, the unknown's in the future. It's out here 3 periods. And is it a lump sum or a series of equal payments? Well, we're dealing with a series of equal payments here, and we're asking the question, what's that going to be worth? So which table value do we use? Well, we're going to use, in this situation, the future value of an annuity table, which in my book is table B4. So we're going to use this table based on 9% for 3 interest periods, and we're going to plug in what we know, and we know that the periodic payment or the equal payment we're making each year for 3 years is $25. And when you look in this future value of an annuity table, under 9% for 3 periods, you get this table value, 3.2781, which means, now look, notice this, that we've put up a total of $75. That's 3 $25 payments. But we're earning interest on this. And so this $75, if you're going to get compounded interest on this for, in this case, 3 periods, that turns the $75 into $81.95. So that's what we're looking for there. Here's our next one. How much would $2,000 deposited each year for 5 years earning 6% amount to? Okay. Is the unknown in the present or the future? Well, the unknown is going to be in the future. And are we dealing with a lump sum or a series of equal payments? Well, we're dealing with a series of equal payments, which is $2,000 each year. And the question is, what are they worth out there in the future? So we're going to use table 4, or the table in your book that says the future value of a series of equal payments, or the future value of an annuity. And we're going to use 6% for 5 periods. And the periodic payment, or the equal payment that would be made each of these 4 periods, would be $2,000. And the table value we're going to get for 6% for 5 periods will be 5.6371. And when you multiply these together, that means that let's see, it looks like we did it for 5 years, so it looks like we're putting up a total of $10,000. And we're going to earn 6% compound interest on that. And so what is simple answer, or what the simple answer here is, going to be $10,000. That is $2,000 times 5 years. If you add the compound interest to this and make the calculation, it's going to end up being $11,274 to the nearest dollar. So if I put up $2,000 each year for 5 years and could earn 6% on it, I would have, at the end of that 5-year period, $11,274. And I believe that is the end of this lesson. No, there's one more. If you invested $2,000 each year for 40 years, earning 12%, it will amount to what? Okay, that means we're going to have to look at asking the question, is the unknown in the present or the future? Well, the unknown's in the future. And are we dealing with a series of equal payments or a lump sum? And we're dealing with a series of equal payments because we've got $2,000 each year for 40 years. And so we're going to use Table 4 again, or the table in your book that says the future value of an annuity or the future value of a series of equal payments. Plug in what we know, which is 12% for 40 periods, and the periodic payment was $2,000. The table value for this would be 767.091, and when you multiply these two together, you end up getting $1,534,182. And I think that is the end of this lesson. No, there's one more. I'm getting a little jumpy here, aren't I? How much would you have to invest each year for 10 years, earning 12% to accumulate $50,000? Now, this is a little different kind of a problem. Let's see. The unknown, well, is it in the present or the future? Well, that is really not a relevant question here because what we're trying to figure out here is the periodic payment you're going to have to make, and we already know the future amount, which is $50,000, and we're looking for these series of equal payments. So this is a little bit different kind of problem. In this kind of problem, we're going to have to use Table 4 because it's going to be the only one that where we have enough pieces to solve the puzzle. But when we use that Table 4, we're going to use 12% for 10 periods because that was given to us, the 10 years and 12%. And what was not given to us was this equal periodic payment. But what we do have is the future amount, the future value of this annuity. So let's plug in the pieces that we know. $50,000 equals something times this table value is 17.5487. And the way we're going to get this something, or these equal payments, is take the 17.5487 and divide it into 50,000. And when we do that, we're going to get those equal payments are worth $28.49. So I could say that if I put up $2,849 every year for 10 years and I could earn 12% interest on this, I would have, at the end of that 10-year period,